Hello friends, in this video we will study the basic functionality of another Python library called Pandas. And this functionality is very useful when you want to work with tables, when you work to reshape tables, when you want to clean the data from the tables, or when you want to provide some summary statistics, which is useful for our future purposes in this course. As an example of for this tutorial, I decided to use the following table. So I created this table myself. It has the monthly stock returns for 35 companies from the United States stock market. So every number here represents the monthly percent return for a particular stock. For example, for Google, IBM, Chevron, Booking, and every date here represents the month. So this is for August, this is for September, and so on, from 2015 to 2022. So you see that the table is somehow huge. Well, if you're familiar to Excel, you may work with this table in Excel, but we will study how to operate with these tables in Python. So first of all, we need to load the necessary libraries. First library is familiar to us, is Numpy. So we import it with the short name NP. And another library that we will introduce today is the library called Pandas. The convention of people who work in Python is to give this library a short name PD. Okay, we import these two libraries. So and then the next step, we need to load this table into Python and store this as some particular object. So first step is to provide the path. So let's call this file name. And we need to provide a path to this file on your computer. So first of all, you need to know what is the path to the folder where the file is stored. So I have it from here. I can just copy this. And I need to paste this path to the folder in the string format. So we know that there is a numeric format, integers or float. This is another format. String provides a text, and Python must understand this as text. So usually when you create some object in the format of string, you need to provide either this single quotation marks or double quotation marks, doesn't matter. So then we put it inside. And in front of the first quotation mark, we need to put the letter R, which says that this is an R string. So there are different types of strings. We don't go deep into their distinction between them. Usually if you don't provide this R, it will not recognize these backslashes properly. So that's why you need to give this here. And the last thing we need to provide is the file name with the extension. So it means that the file is called stocks. It has the extension as XLSX. Here you can see what is the proper extension. So I need to provide this here, stocks.xlsx. So, okay, I have an object which is just a path to my file. Now I need to take this file, load into the Python environment, and store this as some particular object. So first of all, I call this data. And so this data must be loaded. So this table that I showed you must be loaded as data. And for this, from library Pandas PD, I take a function which is called read Excel. I guess the name is quite understandable. And then as an argument of this function, I provide the file name. Well, this will take that table and store in the particular way. So let's try whether it works. Well, yes, it works. And then in the next line, I can, for example, ask to show me this table. Voila, so you see that there are 36 columns, there are 78 rows, and almost all this table is visible here. But usually Python cuts the middle of this table, so you see that you don't see all the columns here, and you don't see all the lines, only 5 first rows and 5 last rows. This is just to preserve the space of your screen. If you want to see the whole table, usually you can do this in Excel. Well, usually when we work with some real data, you want to clean the data, you want to make this, you want to give it the proper shape. In our classes, it's not that necessary, so usually the database has ready to work shape. Well, and one additional thing, so this table is called data frame. So it is a particular type of object, data frame. How you can check that this is a data frame? You can ask Python to provide you a type of this object, type data, and you see that this is pandas core frame, data frame. Good. So some basic functionality, if you want to see only the head of only the first, let's say 10 rows of this data, you can provide the following data.head. So this is a method to the object data frame data head, and then you give, let's say, number 10 here, and you will see only first 10 rows of this column of this data frame. Another function is data tail, which will give you the desired number of last column of last rows, let's say 7. You see that there are 7 last rows. Before starting to work with this table, let's do one important operation. So the left column here is called index. So index is just some name of the row. And you see that in the initial table, we have date as the useful index, because, well, every other column has this index, has this date as the common descriptor, let's say. How to make it? And later on you will see that this index gives us a very powerful, is a powerful tool to work with this data frame. You can do the following. So you provide data equals, so you just want to rewrite this table in the different way. And then you set the following data dot set index. And in parentheses, you need to provide in square brackets and in quotation marks the name of your column. In our case, it's date. And then let's see what will be the result. You see that now the column date changed its location from the main table here, and it is now highlighted with bold, which means that now every row here has the same description, that this is attached to the following, to the particular date. So what it gives us? It gives us very nice way of working with this table. Suppose you want to know what was the monthly stock return for Apple stock in June 2017. You can locate the particular number. So first of all, if you see the physical table in Excel, you need to take this column Apple, and June 2017 is here. So it's -5, 33, 226. Okay, so you just visually look for the desired number. How we can do this with pandas? I ask the following, so I provide data, then there is a method called loc, which is location. And then in loc, I need to provide there two arguments. So first argument is the name of row, and second argument is the name of the column. So the name of the row, you see that the rows are indexed as a date, and the date has year, dash, month, dash, and then always 01. Then I put comma, and then in quotation marks, I put the name of the column, which is apple. When I run this, I get exactly this number, -5, 33, 22, which is here. Another nice feature of indexing with dates, because these are dates and Python recognizes them as dates. Well, not always, but in this case it does. You can do the following. You can provide data, loc, and then you can serve only one argument, the year, let's say 2017. And when you run this, you see that it gives you only for 2017, for all 12 months, the return for all stocks. You can provide comma apple, and then it will give you the data on stock returns for Apple for every month, January, February, March, April, and so on, only for Apple. You see how good is this? You can just simply filter any data that you want instead of visually looking for this data in the Excel table and getting these numbers from there. You can simply extract the particular data from here. If you want, for example, to know what is the stock return in 2018, you can change 17 to 18 and you see that there are monthly returns for Apple in 2018. Well, remember, this is a nice function loc, and we will get back to this function later on because it gives you a very nice and versatile way how you can take a particular subset of your table. One additional thing that we will cover in this lecture is the following. Suppose you want to take only a particular column. So suppose you want to take only a column of Apple stocks. You can do this easily, just writing data and in square brackets and quotation marks, providing the name of this column. So like this. And then when you run this, you will get, oops, sorry, you see that if my syntax was not correct, I provided this APPL instead of AAPL, and then it gives me an error because there is no such a key as APPL. Okay, I changed this to AAPL, and then you see that here is my column. It has 78 rows, and for every date of Apple, I have these observations. The same works with the help of loc. I can ask loc, but now you don't need to provide anything for the first index, and then you need to provide only for the second index. Yes, and before comma, you need to put this column sign. And you see that the result is exactly the same, but this is somehow shorter, right? So we don't need to put too much signs here instead of this. Just can simply write it like this. But be careful because it doesn't work. It works only for columns. It doesn't work for rows. If you want to for example, do something like this. If you want to ask for 2016, it will give you, well, it will give you a correct, somehow it recognizes. But you see that it gives you some warning that, well, it's not an appropriate way of doing these things. So that's why probably it's better to use log whenever you want to specify the exact row or exact column. But if you just want to extract a particular column, this way of working is nice. And one additional thing, the last thing that is related to our course of statistics is the following. So we have 78 observations of Apple stock return for every month from 2015 to 2022. This is a sample. This is a sample. It's not random, or at least to some extent it is random. But suppose that for this sample we want to provide some sample estimates. Sample mean, sample variance, sample standard deviation, something like that. Well, you know how to calculate mean and variance with the help of Numpy. Let me remind you. So if we want to calculate sample mean return for Apple stock. So first of all, we know how to do this. It's Numpy mean, and then you need to provide this string of arguments. Just simply put there as an argument data ABL. So okay, print. Right, here we are. This is the mean. Or you can use another function which is straightforward. You take your column data AAPL, and then there is a method called, after dot you can write mean. And don't forget to put these parentheses there. You see, it also gives you exactly the same answer. So both ways are possible. But whenever you want to work with Pandas, so the later is just simpler. So now, if you want to calculate sample variance for Apple stock, we know that in Numpy there is function var, and we provide data AAPL, and remember that you need, if you want to calculate this as a sample variance, you need to specify the number of degrees of freedom, which is 1, because it shows that from when Python calculates the variance, it must divide by n-1, not by n. Well, let's print it. So this is the variance. So you can guess that the same thing we can do with the help of Pandas. I just call the column of my stock returns for Apple, and then I put it here, var. And the nice feature about Pandas that you don't need to specify the numbers of degrees of freedom, because it already calculates a sample variance. You see that two numbers coincide. I can demonstrate you how it works when the number of degrees of freedom is not specified. Well, calculate the variance with when, oh, let's say we know that this is called the method of moments, or maximum likelihood estimate of variance, which divides by n. In this case, Numpy calculates this in a straightforward way. You see that the number is greater than this. But if you want to do this with the help of Pandas, you need to specify that number of degrees of freedom is 0. Well, basically, Pandas is better because whenever you forget to specify the number of degrees of freedom, Pandas does this for you by default. Here, you don't specify this. Whenever you use Numpy, you need to remember that, well, I must specify the number of degrees of freedom in order to calculate unbiased estimate of a population variance. Now, the same thing is about standard deviation. Calculate the standard deviation for Apple stock. In Pandas it works, in Numpy it works std, right? Data, Apple, and also number of degrees of freedom must be 1. Okay, 822, which is the same as a square root from variance. For Pandas, you can guess that the way of calculation is much simpler. You just specify the column AAPL and .std method, which must provide you exactly the same answer, 822. Okay, of course, you can use whatever you prefer, Numpy, Pandas, but well, it's more natural and maybe more concise whenever you work with Pandas to use Pandas methods instead of Numpy methods. And let me demonstrate you, for example, if you want to specify a particular year, let's say 2018, like here, you are able to do the same thing as we discussed. So 2018 Apple, and let's say I want to calculate a mean. At the same, it is the mean return for 2018. Well, it's almost 0. If you don't believe, we can manually check this number, of course. We can just highlight all the returns in 2018 in Excel, and we can see here the average is exactly the same, 0.003276, which is the same. So that's an illustration how easy you can work with tables whenever you want to extract a particular period of data or a particular subset of data for the particular variable, and then you want to calculate the desired descriptive statistics. Calculate the mean return for 2018. And all these, almost all of these estimates, you may be able to find in the following way. Well, let's also call for the column of only Apple stock returns, and then you can simply write describe. Do this, it gives you how many entries are there, 78 rows, or 78 months. Mean 2799612, which is exactly like this. Standard deviation 822 here. The minimum number 25th quantile, median 75th quantile, and maximum. So the descriptive statistics for this variable. Well, this is another way how you can see the most important descriptive statistics or estimates of population mean, sample standard population standard deviation, but you don't see here the variance. So if you want to get variance from here, you just need to find the squared standard deviation. That's it for today. Thanks for your attention and good luck with your studies. Bye bye.